I tried 3 times already to remember how to say good afternoon in Polish, but I completely forgot so far. But I did understand that you can say good morning and good afternoon is the same way to say it. Is that correct? Amazing. So maybe next time that I come. But anyway, my name is Maish, and I have a question for you all. Has anybody ever deployed an application in production? I hope so, yes. Otherwise, we wouldn't really be. Has anybody deployed a generative AI application or something which uses GenAI in production? A couple of people. It's less, okay, but still. But if you've deployed an application, you know pretty much how the thing goes. You start by working very, very hard to get your application working in production. You spend nights, days, maybe give your AI a lot of work in order to vibe code, hopefully not, but actually to develop the tools for you, and you run all your tests and everything passes, and then you finally get it to production. And you have been working very hard to ward off all these people, your product manager, the CIO, the CTO, the CEO of pressuring you getting the application, and you got it into production and it's working. And people start using it. And then you remember that you have a small backlog of things that you still need to do. Feature improvements, technical debt, enhancements that you would like to do further down the road. And hopefully you've already thought about these things, because if you haven't, I hope you will after this talk, and hopefully put them on top of your backlog and things which are important for you when you start using applications. My name, as I said, is Maish. I am a developer advocate at AWS. I have managed applications in production. I was usually the person who was getting all the problems thrown over the wall from developers before DevOps kind of existed and say, you fix it, I just write code. But these things, of course, have come from managing applications, large-scale applications in production. Today, I speak to developers wherever I can and however I can in order how to use technology and sometimes use AWS every now and again. But I'm not sure if we're going to be able to answer all the questions for, is your application ready for production? Maybe. Hopefully, it'll give you more questions to ask yourself and give you things to think about that maybe you can start implementing inside your environment. So today we're going to be talking about a couple of things. First one is observability and the different topic why this is important. Second is the AI DLC, the AI Development Lifecycle, security, resilience, and of course quality. So in AWS we have a product called Amazon Bedrock, which includes a number of multiple products called also Agent Core, which is a complete platform or service which allows you, managed service to allow you to run agents, MCP servers, and code, all your AI code in the cloud itself, exposing it to however many people and however you would like to do that. Specifically in this case, I'm going to talk about observability only. There's a number of different products within inside that Bedrock Agent Core, but that's not what we're going to be focusing on today. So we all know that you're not going to be able to be aware of your problems in your application unless you actually know what's going on. So if we don't monitor the right things, then we won't know what's happening in the application. So if you're using, for example, Bedrock Agent Core, you have built in with Amazon, with Amazon CloudWatch, which is the monitoring and logging system you have today. There's, of course, metrics which are built in as part of the service, where from the service, of course, you can see that you can monitor a number of different things, such as different invocation counts, how many models were used, how many tokens were used, etc., latency, and amongst a number of other things. But of course, I assume you all know that there is a difference of monitoring from the outside, in other words, from the API, from the service that you have yourself, and monitoring from the inside. Because monitoring on the inside, you actually want to understand what is happening with inside the application itself. And in Amazon, we have an open source library and SDK called Amazon Strands Agents, which is, in my honest opinion, and I could be biased, but that's okay, it is probably the easiest way to create an agent or an MCP server using a generative AI. It's open source, it plugs into whatever you would like, it plugs in much better, of course, to AWS things, but you can use this in order to create your agents and your generative AI applications with relatively minimal amount of work, has a number of built-in tools that you can use today in order to help you work with the library itself. And of course, it is, as open source, it also supports not only Amazon tools, it also supports OpenTelemetry. So if you would like to take those metrics and traces out, then you can also use them in other systems which are not specifically Amazon. But as you can see, there's also metrics and traces. So why are there both as part of the library? So metrics provide us a number quantitative amount of something that happened, measuring something which I would like to see, how much time, how much latency, how many invocations, whatever else it is. And the traces are also very important in order for me to understand what was happening during that time. Strands itself provides you both traces and metrics. So, a bit of a key concept, of course, a session. When we're talking about, this is not specifically Strands, this is on a general term. A session is when a user interacts with a generative AI application from start to finish. It starts a conversation, a number of things. That whole thing which the conversation contains is called a session. Inside every single session, you can have a number of traces. A trace is a single request between the user and the AI on backward and forward. So traces happen in one session can have multiple traces, and each of those traces can have multiple spans. A span is the number of interactions. So I said to AI, please go do X, Y, and Z. Each one of those will be a span itself inside a single request I had for that specific part of my conversation. And using these kind of things, you can use them also in Agent Core. So I want to give you a quick, short demo of what this actually looks like, if I can. Yep. So, no, that didn't work. Let's go back again. And try once more. So in Agent Core, this is what it would actually look like. If you have, this is Amazon CloudWatch, the logging and monitoring system that we have today within it. It's inside Amazon, in the cloud, in the console. You'll see the Strands agent has a application. Over there, you will see different kind of traces, and inside of these trace details, all this metrics and all this information is provided by the code inside the application itself. Drill down, you will get different spans, as we said. Each trace has multiple spans, and you will see all the information specifically based on the code that you've injected with inside your application to give you how long it took, how much a tool HTTP request, and of course the logs, as we said as well. We have traces and logs, so I can get all the full information of the full request going backward and forward within my application itself. Continues a bit more, but forget about it. In other words, here's your logs. This will give you all the information. You can search these logs and the information on a regular basis, see your outliers, and get all information if you need to directly with inside your logs as well, with everything exactly in this actual request and transaction. But as I said, of course, Strands is open source, supports OpenTelemetry. So you can export these traces and these metrics, of course, to third-party tools, for example, Ragas or LangFuse. And of course, this is just an example. This is what it would look like in LangFuse. You can take, it doesn't have to be used on AWS itself specifically. And once we start using this, of course, in our generative AI, the more, and the funny thing, of course, is once you start using things, they start to cost more money. So how do you monitor your cost? In the Bedrock, Amazon Bedrock, there is a specific called hold on a second, an application inference profile where I can start earmarking specific requests based on specific tags, as you can see, hopefully there, where I can start attributing specific applications, specific requests to specific departments, which you get much better insight into your applications itself, how they're actually working, who's actually using your tokens or screwing up your budget for the next year because they didn't write their code correctly. And monitoring will give you, of course, through these different kind of monitoring costs, you can, of course, trace all of these things within Amazon, within the billing system, select budgets, create alarms, etc. But that's the end of the AWS part. Let's go to more general things. Development Lifecycle. The AI DLC is actually quite a catchy term, but I like it. There's essentially, generative AI applications are very similar to non-generative AI applications because they're code, correct? So there's not very much different. There are a few things which are outliers, but this thing is, of course, the same way you would handle your code when you develop applications today with your pipelines, your integration tests, your stress tests, your deployment to multiple different versions or stages of your application to production, dev, QA, whatever it may be. Same kind of thing you would do with generative AI applications. But of course, when you're using things in the cloud, of course, it makes it a lot easier to move from one to the other because everything's done in code. So it's very simple. I want to move to a new environment, a new region, a larger scale application. It works fine. But there are a couple of things that you have to think about when you are working with generative AI applications. And the first thing is how you manage your prompt, or actually how you track and put your prompt into source code. Because when you start working with applications, this is actually part of your application as well. So when you write a prompt for your app, these things, of course, have to go into source code. Track everything, use diffs. If something changed, I know exactly what went wrong when I managed to add an extra 4 words with my prompt and the performance went down by 95%, because whatever it is, you'll be able to do that if you track your applications and the prompts that you put in your applications into source code as well. The second thing, of course, is things that you have to track and also manage are your guardrails. Does anybody not know what a guardrail is? Okay, guardrails are essentially whatever, in other words, a list of rules that you would like to apply to your application, which says you are not allowed to do this or you are specifically allowed to do X, Y, and Z. And of course, these are things which are part of your application, so they also have to go into the source code as well. Sometimes it might be difficult because sometimes those guardrails are managed by another team, because my security team says, okay, write your application, but I want to put a blocker on anything which says or mentions the name of the CEO of the company in a bad way. You're not allowed to provide in my application. So these things have to be, of course, coordinated between different kind of applications and different kinds of teams. The third thing, of course, is the data that you evaluate your application upon. Usually that is something which you do, and of course, I want to run my application, did it work correctly, and I test it on a set of data. If that data changes, your test will change. So that data also has to be versioned as well. I ran a specific test on my application with version 1 of my data, and if my data changed too, then necessarily could it be because my application changed or because my data that I'm trying to work upon actually changed. So these things also have to be work in step with each other. The last and final thing, of course, is the artifacts that you use in your RAG, your databases, your knowledge bases. Of course, these also have to be versioned as well because of the same reason as before. Did my data change, or my applications and my knowledge bases, or did my application and the code that I wrote for it? One thing which a lot of people don't actually think about is, specifically now that we're starting to do more like spec-driven development or prompt-driven development, in other words, writing specific, using our AI to start designing applications from scratch and doing it in a way which we usually do, which is providing requirements, interfaces, architecture design, technical design, all those kind of things. Those documents are crucial to be tracked as well, because this is the logic and the brains and the complete intelligence of your application, essentially, because all these AI tools will be using them in order to help you continue evolve with your application. So these things, of course, also have to go into your source code and start managing, which is slightly different, which we've never done this before, not usually. Deployments, pretty much the same as regular applications. The one thing you do, of course, have to know is, and of course we all know this, things which use LLMs are non-deterministic. So it might get an answer A and might get an answer A plus 1 or A plus 2 or a B. And if you start mixing and matching with different versions of applications and different versions of LLMs, that can exacerbate in a very specific way. Doesn't mean it can't be done, but these, of course, is I'm getting a wrong answer from my AI. Could it be because I am moving to a new version of my prompt, moving to a new version of a model, moving to new data? Again, these are things you have to start thinking about when you're using generative AI applications and deployments in production. Security. Who loves security? Nobody. No, seriously. Of course, there are a number of problems or considerations, not problems, I'm sorry, with generative AI and security. Of course, we have, for example, data privacy, data security, hallucinations, and to really be honest, it's moving so fast that we haven't got a really good grasp on how we do security properly in GenAI. People say do the same as you do in applications, but it's not exactly the same because there are slight differences between a regular application and a generative AI application. For example, a regular application, hopefully when we write code, we have input validation, we process and we get output, and it works exactly the same every single time. That's code. When I do that on a GenAI application, firstly, hopefully the input validation will work, the process will work, the output I have absolutely no idea what's going to happen because it's non-deterministic. So these are things which you have to understand, that when you do security testing, I can't say when I expect my answer to be A, it could be A again, or B, or Z. It could be completely different because it's non-deterministic. You can't really test for those things in a regular way. You can test what I'm not allowed to do, but these will change the way you do security tests. The model itself that you're using could become an attack surface for prompt injection, for jailbreaks. Hopefully we're far past that, but it still happens depending on which model you're doing and which model you're using as well. And last, of course, was the model itself compromised when it was being trained? Hopefully not. I think we're pretty much past that case, or maybe not in certain cases, but of course there are outliers. But in the general sense, we don't really have to worry about, or we don't have to trust 100%, but we can give a certain degree of trust into the model and the data which we're using in order to provide us accurate information. And of course, like everything, you will get hacked. Like, things happen because there's no way to protect anything 100% of the time from everything that you don't know. And when that happens, when using these generative AI applications, you should have, of course, your operational procedures ready for you. An example could be a prompt injection attack. Very simple, actually relatively old, but still. Telling the prompt to do something. So there are ways to defend yourself, and it's usually defined with these kind of attacks specifically in 4 different methods or 4 different layers. The first one, of course, is input selection. So in other words, input sanitization. I can, of course, limit what I'm allowing to accept in my input. In other words, the model can ask me something, but if it says, how do I build a nuclear bomb? I would say, I can provide my prompt not to answer those kind of things. And given with generic, I'm not allowed to answer those things. I can only answer specific things. The second thing, of course, are guardrails, which you can define either inside your application or from the outside, from different companies or different departments to monitor or guard your specific PII information. I don't want anything going out from my layers, from my applications in order for this to happen. Third is, specifically in Bedrock, that is just a single line, as you can see here, where we have a guardrail and amplifier, where you can find that, and so we just enter that specific line directly into the application with their code. Third is, of course, contextual grounding. I have to put this into my prompt in my application to say, this is what you're supposed to be dealing with and nothing else. I don't want you to give me answers on where the best place to book a vacation in the Bahamas is if I have a healthcare application. Those things should be the contextual grounding itself. And number 4 is, of course, the validation. What I'm giving outside, I have to make sure that the information is correct, or at least verified and validated, and only the information that I would like to provide out back to the users. Werner Vogels is the CTO of Amazon, still the CTO of Amazon, and of course, one of the things which he likes to say is we need to build systems to embrace failure, because something is going to break. Always, no matter what happens, in every single company, in every single field, something will break. And it's okay, perfectly fine. We should embrace that, because what happens when these things happen, we have to learn from these kind of experiences, become better, and improve our systems on a regular basis. And one of the ways of doing this, for example, is running game days or simulations of what's going to happen and having an incident response plan. For example, if I have a problem with my model and was jailbroken, these are the certain things I need to do, and have a plan and run through these things in practice. Or for example, if I have another one of an hallucination and my model and application is giving garbage back out to the users, these are the certain things I should go through with a plan already prepared and run these on a regular basis to test them. Resilience. It's actually one of my favorites. The throttling request. It could be any request. It could, for example, if the model is not available. The reason being that you have made a number of assumptions of underlying dependencies for yourself. I'm choosing a model, I'm choosing a provider, I'm choosing a region from a provider, I'm choosing a technology, whatever it may be. But do you have a strategy in place if something goes wrong? What can go wrong? Number of things. The provider stops responding. OpenAI doesn't, the API, they have an incident. Are you using a specific region of, or AWS has a region failure or a brownout, whatever you would like to call it, has a problem with one of the regions. Are you prepared, for example, in this case, to use global endpoints and not regional endpoints in order for that to happen? And if your provider doesn't provide that, there are ways to go around that. One of the things which we see when customers start to fail over to another region because there was a problem, they start and they see, and when they start ramping up their system, they realize, yeah, we forgot to increase all our quotas. In other words, my application will start, but it won't be able to handle the throughput and the traffic that we have up until now because I didn't ask my provider to prepare that environment for me or make sure that it was there when I started. Things which you have to think about as well when you're failing over to other regions or other locations or providers, that capacity should be there for you. If your provider doesn't have an option of failing over from global, you will have to implement some kind of a gateway of your own that can move between regions, between models, between providers as well. If OpenAI is gone, I'll use Bedrock. And if Bedrock is going to use ChatGPT, or I'll use Gemini, or I'll use whatever else it is, because my application still has to completely be there and provide service for my customers. And of course, what happens if everything fails, the world disconnects? What do I do with all the requests that came in? How do I handle them afterwards? Do I just collect them and as soon as I come back online, open up the gates and flood every single system I have underneath downstream? Probably not. There has to be an architectural decision on how you're actually going to do that. Last but not least is quality. What can affect the quality of my application and what the answers and solutions it's providing? So what can affect the actual quality of the inference? Hopefully it works. Yes, perfect. So there could be a number of things from I design my application to provide answers in a certain language or accept input in a certain language, and I change to a different country from Polish to Hebrew, and it's completely different. The answers are similar, not the same. It could be the use case. In other words, I design my application to provide a customer support agent for healthcare, and now somebody is answering me, how do I do auto repairs? It can not necessarily, the quality of the answers and the applications itself will be the same. And of course, the customer base, I designed it for certain people which would use my application in certain web audience, and I found that it was used by somebody else. I have to adapt to those kind of things and make sure that my quality is working correctly. How would you identify there's any kind of drift? The most important, of course, KPIs and KPIs. In other words, you have to have a business KPI or a technical KPI to make sure that your model is working correctly. You can also use human or programmatic evaluation or benchmarks run against certain data, in other words, to test that these things are working correctly or are now slightly starting to drift, not getting what are the results I want. And the most important, of course, is get user feedback. If somebody says, is this a good answer? That's the feedback you can accept from users as well, which will also give you an option of how to understand where your application is not working well. The third part, of course, is how do you handle this? Well, the most important thing, of course, is having the metrics. That you can actually measure what is good and what is now slightly off of good, and how do I start addressing all those points, like I said before. You can change your model, you can change your prompt, you can change versions of your model. That might help you. And you start evaluating again on your data, which has been versioned, as we said, and your reg, which has been versioned, and your prompts, everything according to the DLC. And you start working through this process again in order to try and improve and get your system back to the regular levels that you are looking for in order to get to your customers. I have 1 minute and 50 seconds, which is amazing. So, quick recap. We talked about observability, that you have to have insight into your applications to understand what it's doing from the outside and the inside. Also to understand how the things you're using for cost. We talked about the things that you need to look for your development lifecycle. In other words, how you handle these applications above and beyond the regular code, where you need to look around those certain things, what needs to be also handled in the same lifecycle. We talked a bit about security, how you can implement security in your application itself and make sure that it's not doing what you don't want it to do. Talked about resilience when everything hits the fan, what do you do and how you prepare yourself? And of course, how you ensure that the quality of your application still stays the same and continues to provide that benefit to your customers as well. If you want, there's a quick link for Amazon Bedrock Agent Core capabilities. If you haven't already used it or looked at it, QR code, I'll leave it up there for half a minute or 10 seconds. And last but not least, my name is Maish. I'm going to take questions in a second. On the top right-hand side is a quick QR code for a survey, which I please would like to ask you quickly answers. 2 questions, 100% anonymous, just to hear from you the feedback, how the session was, too fast, too slow, not deep enough, far too deep. I just want to hear the feedback from you because every presentation that I give, I learn more from all the interactions that I have. So please leave feedback for me. And now we can take some questions if there are any at all.
Some questions? Okay.
Hi, thanks. Amazing. Really cool.
Thank you.
Lots of information. I have a question. What if my client needs on-premise solutions? Where should I look at Amazon services?
If your client needs on-prem solution, you can't use Amazon solutions because everything has to be running on-prem. So you would have to deploy the models yourself, all those kind of things you would have to handle specifically on your customer's premises with all the current solutions or as best as possible that they have. Their own firewalls, their own automated testing, their own pipelines, workflows, etc. Everything would have to be done on their own.
So can you give me a good answer for a client who would say, hey, I need these things on-premise, but we say, hey, but AWS is also a solution. How would you approach it?
If you are interested in working quickly and not managing all the cloud of your own on-premises, move to the cloud. If not, you're in for a lot of pain trying to implement those kind of things on premises when you have people which do it much better, much faster for you in the cloud.
Awesome, thanks.
Any more questions?
Any more questions? Okay.
Well, there's one more, yeah.
So at one point in presentation, you mentioned adding more documentation or like the context to the code as
Yep.
part of the code. And how do you approach like the drift between the documentation and the actual code? We as a human, I think we have like a healthy skepticism towards the documentation. We know that like things are deprecated and sometimes you change the code and you don't care about the documentation, or like in most cases, to be honest. But LLMs are very direct, so they read the documentation, the code doesn't match, so we need to fix the code. How do you approach this drift? Like how to keep those things in sync and how to make sure that they are not like misleading the LLMs?
You can't trust the LLM to do it for you. You would have to tell the LLM to do it specifically. So for example, when I develop code or whatever I write things, I said one of the last steps that I have in my implementation plan is go over all the code and the changes you've made and now update the documentation which is already created if anything needs to change. So by putting that kind of practice inside your development practices, that there's always, okay, I made changes, the LLM fixed it. Now tell the LLM to update the documentation based on the fixes. So that would do that kind of process.
May I ask a follow-up?
Yeah, of course.
Because that's a very good question, I think. Follow-up question is, what about implementation as code? Because it would be always easier for everyone to read just code instead of reading code and natural-based language. So that's the matter.
So if I understand the question correctly, you're talking about documentation as code.
Yeah, just don't duplicating the same stuff. Because if code already changed, that means that requirement changed. So why document it really?
Why document the requirement change, or why document the actual code itself?
Why do you think it's better to write like explicit documentation change, a requirement change, if you have a commit that already changed the code?
Okay, that's actually a very good question, because to be honest, sometimes that will work because you can always tell an LLM to start, okay, scan the code, and now you know what the requirements are based on the code that it's created, correct? Essentially, that would work, and it does work. But what happens when you start getting to code bases that are hundreds of thousands or millions of lines long? And you say, okay, I now want to understand what the requirements are. I have to start scanning all the code to get the LLM to provide, okay, the requirements on line 1, line 2, line 3, line 4. Those are the requirements because it'll extract it from the code. If you already have a documentation to say, these are my requirements, 1, 2, 3, 4, it'll save you time, it'll save you tokens, it'll save your LLM and maybe hopefully a couple of trees in the world because of all the cycles of GPUs and whatever running in the background, just to scan that piece of, these are my requirements. This is what I have. I've implemented it in code, so it is duplicating, but I think it's for different usages. So when I'm asking my LLM after I've implemented something, okay, these are my requirements, I now want to add a new feature. So I can either scan all the code to get all my requirements up until now and add an extra one, or I can just scan the requirements, which I would hope to assume that the code already represents. And then I can just continue with that small context piece of these are my requirements, and then start developing more without having to get the actual full mountain body of code in order for that to happen.
Okay, please share.
Yeah.
Yeah, really, really, really good talk. I really enjoyed it. Thank you. And yeah, and I would agree, by the way, with the documentation thing, having it part of the software development lifecycle and having the agents doing it does actually help to keep it up to date, and it will identify if there's a gap and work on it. The thing I wanted to ask about was, I think towards the end, I was really interested in the workload resilience and fallback strategy. The batch inference to handle the backfill, in the last case. Can you explain a bit more about that? I wasn't quite
So
clear.
essentially it will have, in other words, you need to have a mechanism to say, okay, I'm trying to run my application. I have to make a decision. Do I immediately fail and give an answer, no, it's not working? Or as part of my application, the way it works, I can say, okay, your request has been accepted. I'll put it in it's not working right now. I will fit it afterwards. And this, of course, can accumulate to a huge amount of requests depending on how busy your application and how busy a number of requests are coming in. So you can either say, okay, I'll accumulate them, stick them in some kind of a queue, and pull them out in batches in order to, after everything comes back and works, I can start releasing that and giving the information backwards. If it's real time, this is not going to work, of course, because the application is not good.
Yeah.
If it's something which is afterwards on an async kind of method, you can use that. But you also have to think about the fact of how do I release that in batches in one of the things. Do I release everything which is in the queue at the same time? Will probably get you throttled at the other end. And if it doesn't, it will start overwhelming the underlying dependencies and downstream, which will cause problems, what we call the thundering herd. So in other words, the gate opens and everybody rushes at the same time, you can't handle the traffic. So these kind of things are architectural decisions you have to think in your application. How do I handle outages, brownouts, network disconnections? Do I fail automatically quickly? Do I keep the results, tell them to do again? These are things you have to put into your application itself.
Thank you.
Thank you. It is
Thank you so much, everybody, for joining today.
Thanks for presentation.
Thank you. And I'm here if you have any questions afterwards later on, of course. That's not mine.